Okay, people joining this live stream. We are talking about BioSequence functionality, which it seems will make it as experimental functionality in version 12.2, which is good. All right, let's take a look here. Where should we start? Should we start looking at the new system functions and things?
That sounds great.
Okay. Well, let's get a basic sense of this first, and then we'll go into details. Okay, because it's been a while since I looked at this. So we got BioSequence, which is the basic representation of a thing like presumably protein, DNA, RNA.
That's right.
Anything else?
We also have support for circular DNA.
Okay. I don't understand this one. And by the way, the general rule is you don't get to use more than one line in these descriptions.
So noted, yes. So that one concerns whether or not matches must be strict, that it must cover all of the letters that could be, or whether any of the letters that might match a given pattern are sufficient. For example, if someone is given the sequence S, which is the degenerate term for between C and G, does G match?
I understand. Enough said. Yep, I understand. So an N, for example, would match everything in BioSequence match Q, but it would not in strict BioSequence match pattern. Right? It would not. If you wrapped strict BioSequence pattern around an N, right? N is usually, it doesn't know what it is, right?
That's right. So, right.
So if you wrap the strict around it, that wouldn't match a T, for example, right?
That a sequence with N wouldn't match a pattern containing a T if this is true.
What? Is this a wrapper or is this an option?
This is an option to BioSequence match Q.
I don't think it's a well-named option. I think it should be match strictly match BioSequences or something, because this looks like a wrapper, okay, which is what I thought it was. See what I'm saying?
I see. Yeah, I can change that. Yeah.
I'm not completely sure what it should be changed to, but that looks like a wrapper. Okay, I'm just going to do a quick look down here, and then how that's like converting from a DNA to to protein and things like that, right?
Right. That's the super function that can convert kind of anything that can be converted between each other. It builds a graph and makes all the necessary conversions.
Okay, that's nice. And why is there a separate complement function rather than just being convert to other strand?
There hasn't been a notion of other strand, although there could be.
I mean, convert, I mean, these are probably convenient.
Yes.
Complement and reverse complement, but I think convert could also support, complementary, whatever it is, right?
Yes,
right?
Yeah.
Okay. Why is convert a DNA sequence to corresponding RNA? Why isn't that just part of BioSequence convert?
Why there's transcribe and translate?
No.
Yeah.
No. I asked, why isn't this part of BioSequence convert? Transcribe is just converting a DNA sequence to RNA.
Yeah.
So just say BioSequence convert blah blah blah, RNA.
Yeah, that could work. Yes.
Okay, can Michael or somebody else respond about this?
I mean, you had earlier said it would be nice to have the most common terms represented as a function.
And that's probably correct. That's probably correct. Okay, I'm just trying to understand the logic here. Okay. But probably these could all also be supported in BioSequence Convert.
In general, they are.
Yep.
Yeah.
Well, are they?
So BioSequence Translate takes a lot of options or a lot of conversion tables and things. And so it isn't clear how to fit it into the general BioSequence Convert yet.
Okay. Okay. Come on, do not have to put a capital letter there. Okay, good.
It's not the final version yet.
Okay, fine. Number of potential sequences. Wow. There's a lot of detailed stuff about conversions. What does resolve? By the way, somebody's breathing should be adjusted, or their phone should be adjusted. What is all this stuff here?
Yes, so if someone has a sequence that contains degenerate terms, if they apply...
Right, things like, by which you mean N and things like that, right?
N and things like that. If they ask for all of the potential transcriptions or translations or conversions or so forth, that can be a very large number really quickly.
I understand. So what this is, that's interesting. I mean, that's a string replace list type thing, which we don't have for strings. That is saying, in a string, replace an N with either, ACGT and generate all strings, do we? Like string replace list does an operation a little bit like that, but it isn't exactly that.
Right.
So we should understand what the general case of this is. I'd like to know how it corresponds to string replace list. Okay. Okay, so these sequence comparisons would work directly on biosequences, right?
That's right.
That's not great. Okay, so those are linking to entities, right?
That's right. Yeah, there will be. This is in development, as Michael has said. Yes.
Okay. All right, great. All right, let's take a look over here.
It might make, if we start with the things that are slated for 12.2.
I understand. I'm trying to understand so that I know when I'm looking at the design of the 12.2 stuff, I'm trying to understand what it is you are designing for in the future.
I see.
This is not my first design review. Okay. So if I take this, why is it taking so long? Is it loading a bunch of stuff?
Yep.
Okay, so actually you had already done the plus there. Okay, fine. How do I find out how long that sequence is?
So there's both, if you expand it, there should be sequence length in there.
No, I don't want that.
There's also a sequence length sub-value.
Okay. Okay. What's the list of sub-values?
Let's see here. There's type, sequence string, sequence length, and chemical list.
I don't see it here.
Yeah, this is all the review notebook is the latest. I've been updating these, but
okay. All right. Okay, so you're saying If I want to reverse this, I don't get to do that. There's no BioSequence reverse.
That's true. There's not a built-in reverse. That's right.
We had long discussions about this.
Is it not useful?
It's a complicated, like, do we really want more or less to repeat every string function? I mean, we cannot overload them. This is too strange. It's a good question. We had a general operate on function, but it seemed a little bit complicated.
But so the minimum way I can do this is to say sequence string, string reverse. By the way, string reverse you could overload. Reverse you couldn't, but string reverse you could.
I'm sure some people will complain. I mean, we could, but I mean, we could have the same solution what we do for molecule where the BioSequence modify, where you could then do whatever you wanted to do, have 50 different possibilities.
Doesn't sound totally silly. Although modify suggests it's in place. Well, not really.
I was going to say that doesn't really make sense in our world.
Yeah. Okay. Can I say protein instead of peptide, or do I have to say peptide?
You have to say peptide, although we could give alternate standard names and it would work.
That is just a protein, right?
That's right.
So we should allow protein as well. Somebody might want to adjust the microphone again. Yeah, it's nice. It's very nice. So if I say C vertical bar G, will it do the same thing?
That just came back in Michael's review of this, so we're going to include that and also have it round trip so you can get that form out of the sub value as well.
How? With a different sub value?
That's
Something
right.
like resolved string sequence? Or pattern string sequence?
That's right.
Which one? Pattern string sequence?
Yeah, patterned it would be better. Yeah.
Okay, we're going to have consistent names there between these options and such like. Okay. What does that mean? Oh, it's DNA by default. Oh, it's DNA if it can be. It's RNA if it has a U in it. And
That's
so
right.
on. That is an obscure message. Please write that so people can actually understand it. Compatible types. Hello, we're a abstract type inference system, which is not what we're talking about here. Right, just say.
It's neither DNA nor an RNA.
Yeah, that is not recognized as DNA, RNA, or peptide.
You got it.
I thought that's a totally random thing, but I didn't know that BRCA1 had I would have expected it would just say gene BRCA1, not gene BRCA1, comma, some other weird thing. Are there multiple versions of BRCA1 somehow? Why does this, when it says gene, why isn't it just saying BRCA1?
Yeah, it is using the gene standard name there. Maybe I'll make it use the gene symbol instead.
Well, I don't know. I'm just asking this question. I mean, I'm not necessarily complaining. I'm just saying, if that is the gene, it is just BRCA1. It is not this thing with the annotation, right?
That's right.
But what is this thing with the annotation? It's some kind of gene extended name or something.
That's right.
Okay, I just should be understood what that should actually be. I'm not sure. Why aren't we just saying BioSequence here? I mean, everything's reference.
That makes sense.
Okay. Now, what does this mean?
Yes, this means that they're concatenated together.
How can you concatenate a protein and a piece of RNA?
Yeah, it's pretty fascinating. It's something
okay, so
the Emerald
it is
folks,
physically possible.
This was what Emerald especially asked for.
Okay, fine. All right. Okay.
It does not go into the details. What exactly is the clue?
Yes, and also, is it always a string, or can you make like a picture of a dinosaur or something out of? I mean, you can, right?
You can make a network, a non-trivial one.
Yes. So how do we represent that?
Later.
Okay, but have we thought about so this is like an edge.
That's right.
In the network, and later on there might be attachment points, just like there are for molecules and just like there would be for networks, right? But I don't know how we would represent that. I mean, we'd have each individual piece.
It is the factor network, and each edge has a type, and the vertices are non-trivial chemicals that connect the stuff.
Right. Is that really the right name? Type.
BioSequence type or sequence type.
I think sequence type would be better than just type. I think I would use sequence type.
It fits better with the next two.
Mm-hmm.
Right. Okay. Wow, that's wild. These compound sequences may not be happy creatures in the future, because I think they're going to be, as you know, the general network case. What is it going to do here? You know, if you have a bio network here, BioSequence network, for example, or BioSequence graph, much like we have net graph for neural nets, be a BioSequence graph, and then you subvalue that with type, what are you going to get out? You're going to get out, you're going to get out I guess you're going to get out a graph that it'll be very weird.
I think you preserve the structure and just replace the edges.
Yeah, okay, fair enough. It's amusing. Okay.
It's kind of like we have metric graphs would be a categorical graph.
Have what graphs? What? Oh, I see. Right.
Now it gets a little bit advanced.
Okay. Extended BioSequence type. So this is the way that you can introduce your own.
Right.
That's neat.
I mean, that's in general something where we don't have quite a uniform framework within the language, like that allows the same extension for a new numerical integration rule, whatever.
Right, because guess what? These things, their tentacles are very different.
Exactly.
Right. But so this is great that we can do this. So these are ones that we already have defined, predefined ones. Is that right?
Or they're defined by virtue of entity registering them right here. Yes.
Oh, I see. Oh, I didn't notice that you had 3 there. Okay. Oh, wow. So they don't need to say very much then. But if I do this, but then I want to say BioSequence translate, for example, how does it know how to translate Hachimoji DNA into anything else?
Yeah, it doesn't know that by default now.
But you can tell it, yes?
Right now, we can tell it how to complement using these complement letter rules.
Okay.
We could also define a translation. There was a previous proposal for that, but it was rather awkward.
Hashimoto has more letters than the normal.
I'm sorry?
Hashimoto has more letters than the normal.
I know. But so what? I mean, that's so you've got in the translation, you've got to be able to say, I mean, I have no idea what it actually does. Maybe it makes a different set of proteins as well. Does it?
I don't remember the papers who did that.
Okay.
I don't think they had gotten quite there yet.
Okay. Fine.
I think they got it stable. I think that's where they are.
Okay. All right. Okay.
But definitely the translation could be forwarded into this entity store.
Yeah.
Okay. This looks pretty nice, guys. Okay. Let's keep going. BioSequence Q. I understand what that is. BioSequence match Q. No, I don't understand this because we're going to need everything. We're going to need string position. We're going to need the whole ball of wax, right? I want to know where this is on that BioSequence. I want to know, I want to know not just match Q, but I want to know, given this thing where there's a flanking sequence. I mean, look, the typical thing would be, I've got my BioSequence here. That is my random piece of DNA. And I assume that FASTA files will now import by default as BioSequences. Yes? No?
Not yet.
Okay, but there is at least going to be a BioSequenced element for FASTA, yes?
Absolutely.
I mean, that should be trivial. Right, okay, but then what I would typically want to do is take a BioSequence, give flanking, I mean, what I would say is string replace, basically, of a BioSequence, flanking sequence, blah, 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 X blank, flanking sequence, blah, 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 arrow X. In other words, I want to know what is in the actual BioSequence in between those flanking sequences. Does that make sense?
Yeah, that's reasonable. Yeah.
But right now, we would have to have all of these operations, string position, string cases, string replace, all these things would have to be supported. A BioSequence analog of those things would have to be supported, correct?
I mean, this is probably something we want to avoid. This is probably a little bit overkill.
Exactly. So I think one way to avoid it is to study the possibility that we overload the string functions. Okay? And take a look at what that would involve. Because I think that is probably the best idea. And that it is a BioSequence to BioSequence story with the string functions. And that we basically just say string position, because what we're doing is referring to things in terms of the strings. I mean, it makes sense because what we're effectively doing is extracting the sequence string from the BioSequence, doing the string operation and stuffing the sequence string back into the BioSequence. At least in most cases. I mean, we wouldn't do that with string position, for example, which you definitely want here.
But it's slightly more complicated because we take this degenerate ones into account. It's not the literal string operation that we carry out.
Fair enough. Fair enough. Well, I think that's fine. I mean, I think that, but then I would argue this thing should be a wrapper, okay? Because you should be able to say, this section I want NNNs in them, but this part here I want to be strict.
Mm-hmm.
See what I'm saying? Right. So I strongly think that we are, unless we overload string operations, we're going to be in deep doo-doo here. Because let's look at how many string operations there are.
The other possibility would be to have one function that takes as one argument the corresponding string function.
Ali is worried that this will slow down string functions. Don't worry, it will not. Whatever we do will not do that.
No. I mean conceptually, like matrix function. Matrix function takes the function and the matrix.
Oh, I know.
In this sense.
The problem is the multi-argument forms are a mess.
Yes.
I think we need all of this stuff. We need all this longest sequence, shortest sequence, except we need all kinds of things here. I think we should I think we should study the possibility of overloading these. Okay.
It might be a while until all of them can be supported.
Yeah, well, fair enough. So some of them, but look, the minimal way you do it is you just extract the string, do the string operation, go back.
But as I just said, it might not work because of the different meaning of the letters.
I understand that. I understand that. In the case where, give an error if you see one that has non-literals in it. But otherwise, just...
Exactly.
We're going to need all this stuff. All of it. String starts, queue, all this stuff. We're going to need all of that. We should just not try and rebuild it. Yeah, that's an interesting operation as well. That's again very interesting to do with biosequences.
Mm-hmm.
These are all good things, and they should all work rather easily because they're all going to work in the same way. It'll be an up value on biosequence that just looks at so no slowdown of string operations. Yeah, we need all of these. String pad left, we're going to need that too. I mean, all kinds of stuff. All right.
This one you could easily do with the compound ones.
With which compound ones?
But a sequence of sequences you could pad yourself.
Oh, yes, but in that particular case, all right, I admit. And I admit that inserting line breaks is an unconvincing operation in DNA. Okay, so this all becomes string match queue. I think this is fine, complement and reverse complement. Oh my God, we got inverse transcribed as well. Oh, this is getting a little crazy. Do we really need inverse transcribe? I mean, again, there's some convenience things here, but then why don't we throw them all into BioSequence convert after that? When does that ever happen, inverse transcribe?
It's fairly, if people are doing this single cell RNA-seq analysis and converting it back into I hear, even though I say convert right there, so back into the DNA for matching it up. It's kind of convenient.
But okay. Well, whatever. I don't know. I think we should throw a bunch of things into BioSequence convert. And these are merely convenience functions, which effectively call BioSequence convert. Now you're telling me that translate okay, what happens if the codons don't line up?
It throws away the additional terms and gives a message.
And how does it work with start codons, stop codons, all those kinds of good things?
There's a in the future functionality, there's a BioSequence modify that moves cuts everything up to the start codon, and then you can apply translate from there.
But I would have thought BioSequence Translate should say where, I mean, it should have some options saying just go to the start codon and then start translating from there or something. But I mean, what happens if there are multiple start codons?
It should take the first.
And what about, I don't know my biology well enough, all these open reading frame type things and so on, and all the ways that you can get overlapping. I mean, is that just you have multiple start codons and you can start at different places, or how does that work? We don't have Bob here. That's a shame. He would have.
Yeah, it's typically a more complicated story. By the time it actually gets to translation, all of that kind of intersplicing has happened. It's happened between. It happens kind of during the initial transcription. So by the time it
how do we represent that stuff here? I mean, is that something that is there a single transcription, or are there multiple transcriptions that should be represented?
There's really a single one that should be represented, and the rest should be handled through string operations. It's so biologically specific.
Okay, except let me just point out, our market is creatures on planet Earth. We have only one form of life on planet Earth. So anything you say, it's very specific, but we've got however many organisms, and we all work the same. So if there's in other words, there's nothing.
Yeah. It's only as complicated as many organisms as there are. That's right.
No. That's not what I meant. That's not what I meant. If there are generic mechanisms, then we should parameterize those. They should have names, and we should say how to do those kinds of transcriptions, right?
Oh yeah. That's the next phase is integrating the coding region work in genes with this functionality.
So how is that going? What's it going to look like roughly?
I don't know yet.
Okay, but does anybody know? Because we don't want to make sure, we don't want to close this design without understanding that to some extent. Do you understand what I'm saying? I mean, so if I go look up, what's a nice short gene? Anybody know a nice short gene? Yeah, I am picking a random gene here. Okay, here's a nice, reasonably short gene, a cytochrome. Okay, so let's understand what this is saying. And it's really a shame that Bob is not here. Okay, so this splicing structure, I mean, there are a couple of things here which we're seeing, the splicing structure and the SNP positions. I'm also concerned about coordinate systems here. So if I've extracted this biosequence, does it carry around its coordinate position?
Yes. I think it should not.
Or, I mean, if you say gene entity, you'll get back some meta information about it.
No, I understand that, but what I'm asking is, if I look at this biosequence and then I find this thing, TTTAAA, whatever, I want to know where was that, because I want to match that up with a SNP, for example. How am I going to do that?
Yeah, there's a biosequence locate for work following 12.2.
But what do you think it's going to do?
Well, I think it will. You kind of give it the larger structure you're looking in, whether it's the genome or particular chromosome or what have you, and then the sequence is a second argument, and you're returned some alignment objects that tell you kind of where it is, how well it's aligned, and this sort of information.
sorry, you've got a biosequence and you ask that relative to the whole of the human genome, right?
Right.
Okay, but there's a different thing, which is I've got a little piece and I want to know, okay, listen, let's say I've got a collection of whatever these were, CYPB genes, okay?
Mm-hmm.
I've done a big study, okay? I've got a whole bunch of those. And a bunch of mitochondria, for example, okay? And I'm now asking questions about, I'm a little confused about this, how this works. Well, okay, but so let's start off with a splicing structure, right? So this is a rather simple case, but okay, so this is an intron, if I'm not mistaken. So this is being broken into, this is the splicing structure.
Yep.
It'd be nice if we had more spaces around those, but anyway, okay. Okay, so I'm a little confused by this picture. So that's a piece of DNA that we've thrown away, is that right? That's a piece that is going to be transcribed. Then it is spliced together with this piece here, which is going to be transcribed. Is that
That's
right?
right. That's right.
It's kind of a weird picture because this should show ... dots here or something rather than this thing, because this, effectively, this region in the middle is like this white region is going to be thrown away, right?
Mm-hmm. Mm-hmm. Although, I guess there are regulatory differences between the two, but in general, yeah.
By the way, how do I find the molecular weight? So for a given biosequence, can I use, how would I compute the molecular weight of that biosequence? Or the corresponding protein? Maybe we need that as a sub-value.
Yeah. I mean, right now you can get molecules out for small ones. And
well, what about a big one? I mean,
yeah,
it's easy to compute. So why don't you just say protein molecular weight for any biosequence where, you know, which can know how it's transcribed. Now, presumably, if it has ends in it and things, and it's a DNA sequence, there'll be a range of protein molecular weights.
You get an interval back.
Presumably.
But this may be a little bit overkill. Why not have just the molecular weight sub-value, and then if you wanted the protein, you first convert yourself? It seems to me a little bit too far away, kind of asking for the molecular weight or the protein molecular weight of a DNA sequence.
That's true.
Well, the molecular weight of the DNA sequence itself is probably not that interesting to anybody.
Why not for mass spectrograph?
Don't know. No, don't know enough about it. But I mean, this is a typical thing that one talks about.
Right.
Okay. All right. So this spliceability business. So this is ultimately going to be called something like BioSequence splicing or something, and it will be a wrapper around the BioSequence. Right, and then, yeah. So okay, I'm still trying to understand this, the translate and how it deals with stop codons and all that kind of stuff. I'm a little confused. And what it's going to, and I suspect that there need to be more options to sequence translate,
right,
to deal with, you know, what to do. So, for example, if it sees a start codon and a stop codon, that sees another start codon and stop codon, does it return two different translated biosequences in a list, or what does it do?
Right now, it will apply all the way through, so that you'll get
a single thing which has been spliced together.
Yeah, and you'll see there'll be multiple periods in there, which is in the notation for stop codon, which can then be split apart on.
I'm not sure that's right. And I mean, what you've got here is you're looking at the diversity associated with wildcard letters here, which you're putting in a list. But then there's a different meaning to the list, which is the sequence of things seen from different splicing regions and so on. Different, start-stop regions.
Now, by the time translation has actually happened, all the splicing operations have taken place. So maybe the right place to place that is.
I understand that. But if you give me a sequence of DNA here, which has 2 start codons in it,
right?
What is it going to do? And if it doesn't have a start codon at all, what does it do?
So this is what's here is kind of the naive version, where someone just wants to say, what would this be if it was translated as it was?
Okay, fine. So, but how does it line up the codons?
So every 3 from the beginning.
Who knows? Well, that's right. Okay, fine. So that's another thing. That's another option. Is what the phase is when it starts doing that.
Mm-hmm.
Aren't there? Okay. Biology question. I don't know why we didn't have Bob here or other people who know about this, but I mean, when there are proofreading enzymes and things, isn't there a certain degree of proofreading that gets done? If there is an extra character in the DNA sequence or the RNA sequence, what happens during transcription?
Oh, if it's actually in the sequence, it will get translated incorrectly.
No, it won't. No, it won't. Not if it isn't code. Not if it isn't a valid codon.
Oh, yeah. The space of all
There's
combinations.
64 possible combinations, and there are 20 amino acids. I know.
Yeah, and they're all it's degenerate. So multiple codons map to the same amino acid. So the entire space is covered degenerately.
Okay.
I was just thinking, Stephen, did you say, as far as I know, there isn't a wrong codon?
I see what you're saying. You're saying that all of those codons transcribe to something.
That's right.
Okay. All right. Fine. I would like to do a review here where we actually have some more people who know about this molecular biology. This is kind of crazy, because there's a bunch of questions I have which I don't think we're going to know the answer to here.
Okay, I'll try to find somebody.
Ask the Emerald guys, for example. They know this stuff.
Yeah.
And I think our friend Trevor is probably too busy decoding.
That's why we didn't try even to get him right now.
He's absolutely in the virus genealogy business. Although I still wonder what the actual viral clock really is, which is a big question. Okay, the various comments on our live stream here from Vladimir, particularly asking about protein folding, which is a challenging business. I mean, we do have RNA structure, right? Is that in here?
No, we don't have that. No.
But we were about to have that, right?
Yeah, Emerald has that. Yeah, they have. We're giving us some feedback on that, intended for post 12.2. Yeah.
Okay, but so the part that we are going to be able to do fairly straightforwardly is RNA structure, which is vastly easier than protein structure. We should ask our friend Mohammed, who's now winning all the protein structure competitions. We should ask him whether there's something that we could use from his work. Okay, do you know him?
Yeah, we've corresponded briefly. He's a good guy. Yeah.
Right, but he now is winning the protein structure competitions. So let's see if he has something to, and he would also be a person who would know this stuff cold.
Absolutely.
And maybe we should see if he can join us for another one of these meetings. But particularly, it will be fantastic to get some of his modern, protein structure prediction capabilities. Yeah, Ali is pointing out we should have somebody who's a bioinformatics expert. Yes, I mean, this meeting, it doesn't make sense without more. I mean, this is very much an expert meeting, and we don't have the right level of experts here.
Not because we had a couple pre-meetings with them. I thought we zoomed in on the minimal set we would agree on.
Yes, I understand. But you know me, Michael, by now. I'm going to end up asking all these questions about how things work, and it's not going to. Okay, BioSequence convert. What's the difference between convert? Oh, that's the general convert function.
That's right.
Conversion count. What is conversion count? Is it string length of the result?
It's the number of potential results if you called all.
Well, how can it be an interval?
So if there's degenerate terms, or in the case of, how codons map degenerately.
No, you're not answering my question. If it's a count, if it's the number of, is count the possible lengths of the peptides, or is count the number of distinct forms that can be generated?
The number of distinct forms.
Then why is it an interval? Why isn't it just a number?
Because without doing the conversion, because of these degeneracies.
Oh, that's silly. Are you saying you can't figure it out combinatorially?
Yeah, it depends on the identity of what the
What are you talking about? No, it doesn't. Look, it's either a definite number that has, the n either stands for 4 different things, right? What are you saying? You're saying you can't figure this out the combinatorics? Because there's a definite answer to what the number of distinct, if you were to do the conversion, right? Then you would get some number of outputs, correct? A definite number of outputs. There's no interval to the number of outputs you get. You get a definite number of outputs, true or not true?
That's true. You always end up with the same number of outputs.
Okay, so there's no quantum process going on here where we might have an unknown number of outputs. Okay, we have a certain number of outputs. This function, BioSequence conversion count, counts the number of outputs we are going to get. Is that correct?
That's right. Yeah.
Okay,
that's right.
So then what the heck is it doing with an interval? Is that because you can't figure out how many outputs you're going to get?
That's right. Because whether it's, say, a Y or an S, both of those generate potentially two different specific chemicals. But depending on, because of the codons are mapped into different numbers, into degenerately, unless you know whether it's...
Wait. You can compute this, right? So BioSequence conversion count could be implemented as length of BioSequence convert. Is that correct?
That's true. Yeah.
Okay. So you're trying to do an efficiency hack.
That's right.
Estimate the number. Okay. Have you thought about actually doing the combinatorics to figure out what the answer will be? Because I bet that's possible. I bet you just have to have some, finite state transducer that goes down the string, accumulating numbers and multiplying things together when it hits another, unknown. I mean, it's basically a count of the number of paths there are through that finite state machine. Is that true or is that not true?
That sounds plausible.
Okay, so that's a super fast thing to figure out. It's not as fast as knowing just the length of the string, but it's a super fast thing to figure out.
Yeah, I'll look into that. Yeah, I think I can.
I'm not 100% convinced. I think you will overcount with this method.
Why?
Because there will be some that turn out to be the same, and you don't identify this on the way.
I see what you're saying. Right, the path. I see what you're saying. That okay. So Michael,
you will get an upper bound.
No. I think we can do it. I think if we can make. Let me think about this. If we can make a deterministic finite automaton rather than a non-deterministic one, I think if we can do the minimization at the level of finite state machine, we should be able to do it. I don't know whether the thing is a finite state machine. I remember looking at this many years ago. for a completely different reason about how transcription works, and but yeah, in a slightly different context. So I'm not sure. But in any case, I don't think yeah. Okay. I don't understand the point of this function. I mean, if we have this, why aren't we just saying, given this?
No, it's meant for the case if this would return 10 to the 32.
Yeah, I understand. But why don't we just have something which produces a message if the number is ridiculously large? It just seems like nobody's ever going to call this. They're just going to call BioSequence convert, and then it's either going to blow up their machine or it's not. And I mean, maybe we can have a max items option to BioSequence convert, which is by default set to some number, 10,000. I don't know what number it should be set to. Okay. And if you really want everything, you set max items to infinity, and otherwise it will limit the max items with a message. See what I'm saying?
Yeah, that makes a lot of sense. That's a much more straightforward path.
Okay. All right, fine. I mean, being able to estimate this would be nice, but I think it seems like a luxury item. Okay, resolve degenerate letters. Why are you calling them letters?
I guess because they're part of terms in an alphabet.
Well, that's just an analogy. I
should say we're not entirely happy with the name here. There are some other candidate names that we came up with shown below that result, but certainly we're open to
that one is
suggestions.
better, resolve degenerate. I mean, this is something that we don't have. Like, if we have a regular expression, we don't have a function that says, partly because the number could be infinite, resolve me all the, like we could say, give me all the sequences consistent with this regular expression up to some length. Is this actually useful, this thing about resolving degenerate forms like this?
Oh yeah, yeah. It ends up, I guess, mattering quite a bit as to what peptides you could convert to, among other.
Well, I understand that, but that's in BioSequence convert. You just convert, right? So why do you need to You know what? This is a silly function. Why don't we just have it be part of BioSequence convert?
Okay.
It's convert to itself. It's convert from DNA to DNA, but resolving because it's going to do exactly the same thing. It's resolving those degeneracies, right? But if I said here, just convert from DNA to DNA, I would get the exact same thing, correct?
Right now, it doesn't resolve degeneracies, but let's make it so that it does, and that
wait, excuse me. What do you mean it doesn't resolve degeneracies? What's this?
No, I mean, if you said convert DNA to DNA.
Well, it should.
It should.
What does it do right now?
It's an identity.
No, well, I don't think it should, because it would violate the principle of the shape of the result.
Well, but it's doing it here. Look at this case.
But there's a third argument.
Oh, well, okay, then it should do. You're right. It should do it in the case of the third argument. That's how you should get.
Okay, fine, good.
Okay.
Yep.
Ali is correctly pointing out that the name for the function should be resolve degeneracy if we had it, but I don't think we need it. Yes, PLT is pointing out a codon on nucleotides. 3 nucleotides is 1 codon. Yes, then mRNA is like a little machine. Indeed, that's That's why I'm yakking about finite state machines and the ribosome acting like a finite state machine. Wild. Does that actually make any sense? Doesn't the thing need end caps of some kind?
Yeah.
Oh, it has, you say no cap DNA.
Right. There's.
What is this? I don't understand this. BioSequence here. What's the second argument to molecule? I never saw a second argument to molecule. What's the second argument to molecule?
Right. No. So I haven't talked with. So we need to come up with a better. What do you?
Hey, by the way, there's a bug
here
with the raft disappearing. Somebody should report that. That must be a 12.2 bug.
Tom Sherlock knows.
Amazing. That goes wrong almost every version. Okay. In any case. Okay. So sorry, Jason. You were just saying.
Right. So that's not the syntax that we would land on in the end. Is to. Right. So if you need options for how to convert a biosequence to a molecule, then it would need its own constructor function, right?
I think it should be part of biosequence convert. Why not? Biosequence convert to molecule, and then you can have, you could say no cap DNA molecule, and then it happily returns a molecule rather than a biosequence. Be my suggestion.
Yeah.
I mean, the case where it's just a straight conversion, but explain to me about the end caps. Somebody explain that, or does anybody not know? Nobody know here. I just don't think that can possibly be right. I think this is just a purely notional thing. I don't think that works that way. And isn't that the same? You got to have somebody in here who actually knows this stuff. I'm sorry, this is wrongly set up. Okay, in any case. That is wild. That is a wild creature. Look at that wild creature. It's entertaining. I give it that. But why isn't that random sequence DNA quotes NNN? I mean, that could be a shorthand for NNN and NNN 50 times.
It actually, BioSequence DNA, comma 50 is the shorthand for NNN 50 times.
Okay, fine. So I can as well say here, if I wanted to, I could say something like this. I could say NNTS. Is that so? I don't remember what the S is, one of those things. Oh, Coolosaurus. Okay, that's nice. It's a little funky. It's like, I mean, gradually random instance is going to be used in more and more places, but right now it's old Euclid and biosequences. Are there any others?
I don't think so. I think that's it.
What's that?
Nothing else comes to my mind.
Okay, is this consistent with the way that random choice works?
Yes.
I think so.
Find out, because the raft is going away. Okay. So what you're saying is there's a similarity rules, which we already had, didn't we, for sequence alignment?
Yeah, this builds on the existing similarity rules option. Is that the right term? Genetic translation table? I believe so.
Okay, all right. That's cool. All right, fine. It really is amazing how everything in this world is computational at some level, including, as we now know, physics. But the fact that this is so structured is really amazing. I'm just sorry, that's just my little
It is quite remarkable.
Just think about all those organisms that lived and died, making sure that that some particular letter here was the thing that won out in some struggle for life back in the Precambrian or something. Anyway, never mind. Frozen history or something.
Okay, so we make some changes based on your remark, make the convert much more general. Think about the various string functions, and then
yes, the string function is probably the biggest thing. And let's do one with some actual experts.
Yeah.
And more experts.
And the string function, I said, I don't think we will be able to support them all for 12.2. This might be.
I understand, but look, just support.
What do we do if we need some more options that are not available?
Talk to me about it.
Okay.
I would generally think we could just let them work in the overloaded forms of the string functions.
And basically have anything in the pattern rather than as an option to the string function.
Yes, and that strict degeneracy, that thing should be a pattern wrapper.
Yeah.
I mean, look, at some level it's a hack to use letters, but it is the standard hack of bioinformatics, and I don't think we should, it's silly. It's just like we say, it's an interesting question, all right, whether we should support in naked strings a wrapper that means this is essentially a bio. That's effectively what we're doing. We can have the pattern be a BioSequence. Right, both the thing that is being looked at and the pattern could be.
I was wondering about this. I didn't like this scenario because, like, for molecule we have molecule pattern. For strings, it's slightly different.
Well, think about it a bit. Okay, what I'm suggesting is you have a naked string, but you want to do matching, BioSequence-like matching, where n can match any of whatever. Right? It's like saying, it's like the annotations that we have for string matching that allow different sort of special, like regular expression is a good example, where we're taking a string of characters but interpreting it as a regular expression. This is a similar kind of thing.
But then you might also want to zoom one level out, and we need to verbatim support it.
No, we don't. Not for strings.
No, I speak about BioSequences. We want to match n against the literal n and only a literal n.
Well, that's exactly what you've got with that. The result, that strict non-degenerate thing. That's exactly what that is. And possibly we should just use verbatim for that. So I'm saying in the sequence matcher, right here, wherever it was, where you've got this function, this strict BioSequence pattern, why not just use verbatim? To say verbatim n in the pattern, just like we would for a regular string pattern. Actually, I don't think we need to do that in a string pattern, but we would do that in an expression pattern.
We would use it for star, say, in the string.
Yes, quite. I think you should use verbatim for this. It's very clear what it means. All right.
I must think if this covers all cases in both directions.
I'm not sure. Yeah, I'm not sure. But if not that, it's some kind of thing like this that is a wrapper. Oh, we have 2 more questions on our live stream. What how to compute mutations? I mean, that's what the whole sequence alignment stuff means here. Again, I'd like to know. Yeah, I assume we've looked at other, at systems people use for bioinformatics. And for example, I know whenever I go looking at my genome, which I have to admit I do rarely, the typical thing is I want to find this particular SNP, or I want to, and I typically do it by just matching with flanking sequences, because I've given up you know, which build of the human genome is this, et cetera, et cetera, et cetera. Yeah, anyway, okay. Okay, we had a question from Ali. Is there a meeting on computational geometry coming up? I do not know. I see a meeting about synthetic geometry on Thursday. That's not quite computational geometry. I don't know. Good question. I know there will be before 12 too, because there's a bunch of functionality there. I don't know exactly when it is. All right. Well, thanks to everybody here. And Michael and John, I look forward to seeing the next iteration of this, but it's looking good. Looking good.
Thank you.
Okay. And thanks to folks on the live stream. See you all later.